Hey everyone, Dr. Crayhay here. So right now we're discussing Chapter 1, and I just wanted to provide a few brief lectures, really just overviews of some of the topics that I think are most important from this chapter. So in this video I'll talk about the theory data cycle. So that starts on in the second edition of the textbook. We're on page 9, so if you wanted to follow along, that's where I will be lecturing from. So before we even get to this wonderful picture here provided by our textbook author, Dr. Beth Morling, let me define a few things for you. So first of all, we have a theory, right? So we need to understand what a theory is. So your textbook defines a theory as a set of statements that describes general principles about how variables relate to one another. Now, conventionally, we might think that a theory is, well, I have a theory about who's going to win the Super Bowl this year. In science, that's not what we're talking about with a theory. In science, a theory is based on numerous observations. It's based on multiple scientific tests. So it is something that's a little bit more than just your everyday average, well, I have a theory about so-and-so. It is more rigorous than that, so keep that in mind. A hypothesis is it's a prediction. It's basically what you expect to happen from your research. So you may have heard a hypothesis described as an educated guess, which is mostly true, but is problematic for a couple of reasons. The idea that I want to get across to you right now is that hypotheses are not guesses. They're really not. So you have to read previous research. Based on what other scientists have found, what do you expect to happen in your study? That's what a hypothesis will do. Data are a set of observations. So this could be, depending on your research scenario, data will come in different forms. In this class, we'll deal with data that is all numbers that we can stick into a spreadsheet and we can get statistics on. Data might be a bunch of words, so maybe we go out and we interview people and we want to know what they're saying. Data might be just, watching people or animals and seeing how they behave. So data can take several different forms depending on your research scenario. So let's talk a little bit about Harry Harlow before we come back to that wonderful graph. And so the contact versus comfort theory. So this, in your textbook, they talk about, what do they call it? The cupboard theory, I think, versus the comfort theory. So the idea is, animals get attracted to their caregivers. So if you have a dog, you'll know that when you come home, your dog gets really excited. Why is that? Are they excited because they are like a cupboard? You're like a cupboard to them, you feed them, and then they associate the positives of getting food with you, and so they like you? Or is it because of the attention that you give them? Because of the social time, the positive praise, all of those kinds of things. So we have two competing hypotheses, right? So are animals bonded to caregivers because of food, or is it because of comfort? So we have two different competing hypotheses. So what Harry Harlow did is he set up this study. You probably learned about it in intro psych. So on the left here we have just a wire cage that provides food. On the right we have a terry cloth mother, so a wire mother, sorry, I shouldn't have said cage. That's what it looks like. But it's just a wire mother that does provide food. On the right there we have a terry cloth mother. It does not provide food, but it is warm. So it's warm and it's soft. And so Harry Harlow wanted to know, will the animals prefer the mother with the food or the mother with the comfort? And so he watched these baby monkeys for quite a bit of time. He tested different monkeys, all of those kinds of things, and he found that the monkeys would stay with the terry cloth mother, I believe it was for 18 to 24 hours a day. Oh, no, 12 to 18 hours a day, sorry. But it was still the majority of their day they spent with that soft mother. And so what would happen when the monkeys get hungry, they climb down, they go to the wire mother, They eat, they get down off of that mother, and they go back to the comfort mother. So they were showing a strong preference for that mother. So what Harry did, he had an idea. He had a problem. He came up with a hypothesis. He found a way to break these things down. He needed to separate the food versus the comfort. So that's what he did here with this scenario. And then he tested it. So the data that he got most likely led him to more questions. And so ultimately he ended with this beautiful study that just illustrates it fairly perfectly, I think. And it probably took him quite a while to get here. So that's one example of the theory data cycle, and so I'll reinforce that right now. So you have a theory. You've been reading existing research about a certain topic, and you come to think, well, what about this? And so you pose particular research questions. So, what are the effects of Prozac on depression? Just to go with the typical psychology example for you there. You pose a research question, which leads to a research design. So you decide, how can I study this? Do I do it through survey, through observation? Do I need to do a drug trial? All of those kinds of things. And then you come up with a hypothesis. How do you think this will work out? Run your study, get your data, analyze your data, get the conclusions of your study, and what that will do is get you back to a new theory. So let me give you an example with my research. So I was in my first year of graduate school, and I was learning about something called flashbulb memories. So these are memories that are really vivid, really intense, really strong, and people think that they are well remembered even after long delays. So the typical example for this, and I know students are starting to get a bit too young for this example, but the typical example is 9/11. So many of you probably remember where you were when you heard the news, what you were doing, maybe who you were with. Some people remember what they were wearing, but anyway, you remember a lot of particular details about that day. Other examples, when Princess Diana died, the Challenger explosion, the JFK assassination, all of those kinds of events tend to form flashbulb memories. So I'm reading this flashbulb memory literature, and it occurs to me that none of it is on a positive event. I haven't seen anything published on positive flashbulb memory. So that leads me to a research question. Can you form a flashbulb event for a positive event, a flashbulb memory for a positive event? That led me to a research design. So the best way I could think to do it at my university with my resources was to look at students rushing for a sorority. So they go through a week-long rush, and then they go through a formal ceremony where they're either told you're in or you're out. So I wanted to know, could this form a flashbulb memory? Get to hypotheses. I thought absolutely it will. I thought it would follow the same exact trajectory as a normal flashbulb memory, meaning they'd remember who they were with, what they were doing, all of those things leading up to the announcement. But when we tested them a year later, that data would prove to be inaccurate. So it would have the same misrememberings of typical flashbulb memory. I got the data, so I did a year-long study on this, following these students over time. I get the data and come to find out, yes, it was absolutely a flashbulb memory. But the details were remembered incredibly precisely. So they would say that they were with Sally at time 1. A year later, they would remember they were with Sally. They could quote some of the things that were said a year later. So there was this interesting diversion from what I thought would happen. I thought there would be misrememberings, but it turned out that they were fairly consistent across time. So that led me to think, how is this study different from the existing research literature? And it occurred to me, JFK assassination, 9/11, Challenger explosion. These are all national public events. My event, a sorority, rushing for a sorority, that's a personal event. So we go back to theory and we wonder, okay, if I could find a positive national event that leads to a flashbulb memory, and you start all over again. Which I did, actually. So I had a theory when Osama bin Laden was killed. and Americans took to the street. I was down in Texas at the time. People were shooting off fireworks, celebrating, so I thought, hey, maybe this is the positive flashbulb event we've been waiting for. People seem very happy about this. So I came up with my research questions, research design, hypotheses. A year later I have the data and I realized, nope, not a flashbulb memory. So then I have to think, why wasn't this a flashbulb memory? And then go back to the top, to theory. So it is a very, it's a repetitive process. So every time you do a study, you learn something new, you revise, you go back to the top, and you try to investigate that new thing that you just learned. You go back to the top and you keep redoing it. Actually, people make careers of this, investigating one single line of something. They'll keep doing this, keep doing this, keep doing this, until they think that they've really gotten it figured out, or until they get frustrated and want to change direction. That happens as well. So this is the theory data cycle. So when you see a scientific theory, it's not that someone was sitting around at home and had this idea. It's not that at all. Instead, it's that they did rigorous testing. They thought about it, they compared it with previous literature, and they're looking to the future for new evidence. So that's it for the theory data cycle. I'll record one or two more on Chapter 1, and just keep an eye out for these lectures as we progress through the course.